Welcome to the last week of the course, where we're going to talk about business or enterprise AI applications. So let me start with an area that most people are very interested in and has been had explosive growth in the last 5 to 10 years, and that's sports analytics, all the data science problems and machine learning problems that have come about in sports. So let's start with the English Premier League, the EPL. And there's a whole bunch of links here. So if you go through and click on the links, you will have 4 articles to look over. And again, in the last 10 years, there's been an incredible increase in the use of data analytics in English Premier League, starting from the amazing, I think, 5,000 to 1 odds of victory that Leicester City had in 2015, 2016. A more recent example, 2021, is Brentford Football Club in 2021. Okay, so there's some links for you to take a look at. What type of thing will you find? So I found an interesting article talking about pitch control by Liverpool. There was a very famous goal scored. I think it was Liverpool Huddersfield, and Liverpool scored in the first 15 seconds of the game, and they'd essentially mapped out exactly where they were going to pass the ball from the kickoff, where the weak spots were in the defenders, exactly who was going to run at who, and result in a goal scored in the first 15 seconds. So here's an article again. If you click on the link up here, the data science team at Liverpool created these things called heat maps. And so the red areas, no pun intended, given that Liverpool are the Reds, are the areas where Liverpool can get to sooner than the blue players. And the model, based on a logistic regression, estimates how much more likely you are to score a goal within the next 15 seconds if you can do that. And scoring a goal is very rare, so a 1.3% increase, compounded up over a game of 90 minutes is quite substantial. Okay, so lots of video footage. Let's take another look at another example. So there's a YouTube video down here where somebody built a model for sign stealing, and I guess that was rather topical at the time, given the Houston Astros scandal, where they were sign stealing with machine learning video methods and using drums to signal what was happening. So the catcher here can use a bunch of different signals: touching a cap, touching a nose, putting some fingers down, and to suggest what type of pitch to throw. And again, if you look at the video, there's some neural network model here that does the mapping from input to output, and so you can figure out from video footage what the pitches are likely to be. So quite interesting. Uh, Clubs have gone to great lengths of looking at different limb movements to find optimal swings, optimal pitches. So an example of that, I think the latest technology, 2021, before they would put sensors on the pitcher and would try and figure out what was optimal. Now they just take videos and come up with deep learning models. So you can see different skeletons of people from setup to maximum lift to foot strike to release, and you get plots from the video footage, so the pitcher can get some feedback on what he's doing well. So I think the interesting thing here is that sensors have been replaced really by neural networks that just extract data from these biometric reports and from images and video footage. So the company doing sort of groundbreaking work in that is called Kinetrax. Another interesting, there's a huge amount of baseball statistics. So another interesting model in the last 5, definitely 10 years, that the way that fielders have placed themselves in the outfield on a baseball pitch has changed dramatically based on the likelihood of where the batter's going to hit. And again, there's lots of these statistical models where video footage is being recorded. And again, a logistic regression type model. You want the likelihood of a ball to be caught by an outfielder as a function of a bunch of input variables: opportunity, time, distance needed, and direction. And a couple of my ex-students have gone on to work at data analytics teams for these baseball teams. So Zach Aldrich is one, has a good time and very interesting jobs, and a lot of interesting data to look at and modeling to be done. So can I predict the probability an outfielder will catch a ball as a function of variables? And in some sense, you're looking for outliers. You're looking for, who's the most valuable outfielder, similar to the Moneyball. Again, Michael Lewis's book Moneyball sort of started the whole game of looking at data analytics and trying to value players as a function relative to some underlying basic statistical model. So a huge amount of work put into that. Another interesting and actually quite complicated statistical modeling problem is to look at spatial temporal patterns. So to understand how, for example, in NHL, as the players move the puck around the rink, and also, of course, the NBA, what's the optimum approach to moving the ball around a basketball court, and what's the optimum type of shot to take? Again, I think analytics changed the way that people took shots in the NBA, put people more likely to take 3-point shots than before. And again, in hockey, there's a lot of video footage of knowing exactly, given the position of the players on the rink at any given time, and given what each objective function that the player is supposed to be looking at, what's sort of the optimum path. I think if you go to Google Analytics, they have, so it's really like a reinforcement learning algorithm, a little bit like our robotics. There's a state of the system here, spatial and temporal, and then there's an optimum action that you really want players to take. And again, a lot of this stuff is to give feedback to the players of what they should be doing in certain scenarios. And I think if you go to Google Analytics, they have a reinforcement learning algorithm that simulates EPL games. So again, you don't just have real-time footage of specific players. You can also simulate situations, and you can see, okay, what's an optimum path for scoring an NHL goal. So a lot of these things getting optimized. One of my ex-students, Mac Darrow, who played basketball at Princeton, told me about this, and I think a couple of his friends have used it. There's an interesting company called Home Court that basically essentially lets you use your iPhone to take videos of you shooting and practicing at home, and then make suggestions for you, and sort of compares you to the great players. So if you're trying to make a 3-point shot, maybe you want to be compared to Steph Curry, so you can see what's the difference. Again, there's a lot of data processing, image recognition, finding out what the optimum shots are. And again, just like the Kinatrax baseball example, really the images and data processing, the NVIDIA type stuff, has gotten rid of the use of, you don't really have to put a whole bunch of sensors on yourself. It'll give you these interactive drills to improve yourself. It's really made, taking a shot really a science. And I think another interesting competitive advantage that they have is, and again with all of these machine learning algorithms, we'll talk about it more in a minute, that the person with the largest, biggest data set sometimes really has the best information, because the machine learning tools are sort of off the shelf. The deep learning type stuff is or logistic regression is off the shelf methods. And so the person with the best data set will no doubt come up with the best insights. Okay, so that's Home Court. A topic near and dear to my heart. William Benter, Mr. B, was somebody that implemented logistic regression with 80 variables in the Hong Kong racetrack. and made a lot of money by gambling over many years. There's a whole bunch of other people have looked at these things. One thing that was very popular starting in the 1980s, I think Robert Sangster, one of the famous. So one of the most interesting examples is applying data analytics methods to picking which horses to buy. So most horses are bought in the yearling sales, and they're not fully grown at all. So and it's incredibly hard to predict when they get to the racetrack at the end of the 2-year-old or beginning of the 3-year-old career how good they're going to be. Just to give you some sense, a horse called Street Sense that won the Kentucky Derby, I think Shea Mohammed paid north of $100 million for. A very famous English horse called Frankel sold, I think, for like £250 million, some incredible sums. So there's a huge science to trying to pick, what are the good horses in the yearling sales. So essentially, you're looking at a baby and then trying to figure out, okay, are they going to be a really good runner when they're fully grown? And as I said, Robert Sangster and Vincent O'Brien in the 1980s came up with heart size measurements. I think there's like 17 different measurements of heart sizes. And before people realized that they were collecting data on heart sizes and buying horses. There were some classic examples of, I think Seattle Dancer was somebody paid $17 million for because it had incredible breeding from Seattle Slew and Northern Dancer, and essentially got to the racetrack once and was essentially last and never raced again. And the problem there was, even though he had great parents, had a very small heart. And rather interesting, a more recent example, American Pharaoh, who won the Triple Crown, and I was lucky enough to see run, had a very large heart. But Secretariat had the largest heart of all, I think £9 3 or something. And the typical average heart size for a horse is like £4 6. So Secretariat's heart size was essentially double that of the average. And I think the next biggest one was a famous Australian horse called Far Lap with, I think, £6.7. So you can see the incredible spread. So there's a whole bunch of not just looking at racetrack output data like William Benter has looked at of trying to predict the winner from previous winning times, but there's also a lot of data analytics in trying to assess which horses are going to grow up and become really good athletes and performers. Okay, another another sport that's really been changed by data science, where artificial intelligence came in and totally changed the way things were done, is Formula One. And now all strategies and the way these teams are run is like an incredible science. Everything is done in real time. Optimum strategies can vary very quickly from moment to moment. Formula One realized that having a whole bunch of data scientists instantaneously giving feedback to drivers like Lewis Hamilton was a huge advantage. So now teams are limited to 60 data scientists at a time. And again, you'll see examples like this. There's a link here. If you click on the link at the top, you'll see a discussion of a data set. Typically, a Formula One race is 200 miles long, 70 laps of a track, and they've got a huge number of sensors on a car that's giving real-time feedback. So you get millions of data points per race. And of course, it's a very simple objective function. What's the fastest way from start to finish? And there's a whole bunch of variables. And one of the more important ones is tire degradation, fuel load, for example. And again, there's lots of sort of optimum strategies. So, for example, trying to predict, what is when is the best time to try and overtake somebody if you're in second place, et cetera, et cetera. So a big science behind Formula One, and I think for some Formula One races, data scientists have even put up probabilities of predicting who's going to win the race given current positions. So to try and make it more exciting for the people watching. People are trying to use analytics to give feedback on what's really happening. And again, everything is done up on on the cloud. So Amazon Web Services provides all the data analytics and analysis as things are going along. Okay, so hopefully that gives you an idea of sports analytics. As I said, there's nearly every sport has been changed, from English Premier League to rowing to lots of other things. So hopefully that will give you some idea. So let me now talk about enterprise applications. So for an enterprise application, let me think about Airbnb. So nearly all these big internet companies like Airbnb, Zillow, and of course the original ones, Google's, Facebook's, Amazon's, use a lot of data analytics. And again, remember the website Kaggle. Lots of these companies put up competitions to get feedback on what good models are. And Airbnb's users are growing exponentially. And you get a whole bunch of feedback from a whole bunch of sessions, and you want to try and figure out what's going on. And some of these things are in some sense quite simple. When a new user logs on and you don't have much information about them, you want to make their experience as simple and easy as possible. And you want to try and figure out where they're going to make his or her first booking and what kind of things to recommend to them. Mainly to make it easy. And there's lots of different effects, of course. There's once you start to look at these data sets, there's lots of missing data. You don't have full information on everybody. There's lots of gender effects. There's lots of age effects. So you can already begin to see different variables of where the different people of different ages and gender want to use and go to use Airbnb. Again, you can look at underlying. Don't forget your basic exploratory data analysis before you fit any sort of pattern matching algorithm. You can look at destination by place, by age, by category, that type of stuff. If you look at Kaggle, lots of different ways. Sometimes people will look at XGBoost, which is like a tree approach method to these things. Sometimes they'll combine lots of different models. I think we looked at an example once, and sometimes in terms of deep neural networks, one of my favorite activation functions, essentially just fitting hyperplanes. So it's a bit like a generalization of trees. Essentially, you're doing ReLU, where the activation function is a maximum of x and 0. So Airbnb has a big team of data scientists and interesting problems there. One problem I've worked on with one of my colleagues, Vadim Sokolov. He works at George Mason University. So I'm sure you've all seen these Google Maps, and I'm sure you've all used Google Waze. It'll recommend what the optimum route is to get from A to B. So if you want to go from Washington, D.C. back to George Mason, what's your best path? And so again, you want to think of these assets that companies like Google have, like Google Maps, as like an operating system, like speech or language. And so having Google Maps is incredibly valuable. And as the years go by, Google Maps will generate more and more revenue and income for Google. And it's hard to compete because they have an incredible data set. And they've got a lot of machine learning tools that are placed on top of it. So, path search algorithms to optimize given current conditions requires quite a lot of effort. So, interesting problems. Lots of traffic flow problems. Iowa uses deep learning, believe it or not, the Department of Transportation, and uses TensorFlow to try and help when there's a lot of snow and try and optimize snow routes to provide better traffic information in Iowa with snow. In California, I guess not much snow, but how do you identify potholes and dangerous cracks in roads? So how do you automatically do these things and report back and hopefully get these things fixed? So there's a huge set of applications of machine learning methods in traffic type problems. We've talked a little bit in the robotics section. We talked a little bit about what does Tesla's autopilot car use. Well, again, just to remind you that Tesla employs these massive neural networks on these big data sets. And again, there's a big competitive advantage. You need a lot of computational power. you of course need a lot of training data, and need a lot of sort of resources of developers and programmers to get these things to work. So Tesla's autopilot, one of their successful features. And again, if you think of a Tesla car, a lot of it is based on software. And so, as these technologies get better, you can just sort of update the software. So, in some sense, your Tesla car is getting more valuable over time because it's improving. So, there's a famous problem in economics called the cost problem for durable goods, and in some sense, these AI algorithms are really creating a lot more value for goods that you have, because you can update their capabilities as the technology improves. So Autopilot version 9 is one where they've added a lot more neural network stuff and basically improved it. Okay, I've got two. There's a hyperlink sitting in here. Uh, I've got two links on sort of large scale industrial applications of AI. And these sort of surprised me when I saw them, so it's worth clicking on the link just to see the videos. So Rotterdam is one of the largest ports in Europe, in Belgium, and believe it or not, this incredible big port is run by 10 to 15 people a day. So if you click on the link, they're very proud of the fact that they've used and put together all these machine learning methods to automate Rotterdam port. The Chinese equivalent, again, there's a hyperlink for a video, is the port of Qingdao. I think it's the largest. It's a terminal with the largest amount of copper, and that gets imported from Rio Tinto and in Australia into China. And again, if you click on here, it's known in China as the ghost port. And maybe no is a bit extreme, but it's this absolutely huge port, and really has very few people. And this it uses all of the technologies that we've talked about: smart autopilot trucks. They even know when it's time to go and recharge. And again, if you watch the video, you'll see the track marks that these things make for moving these huge big containers are basically perfect. So you see these rather beautiful patterns on the concrete of where the trucks have travelled, and you get rather pretty patterns. So these machines are so precise, and of course they can lift and move these big containers at will. And again, they've put these things all into driverless trucks. So if a huge big port can be automated, just imagine what can be done for most things. So AI really has been implemented on a grand scale. Oh, and just to touch on that a bit more, Rio Tinto, one of the largest copper companies in the world, mining is a dangerous business, and so their Pilbara mine in the north of Australia, dangerous to work there, and so they've put a lot of the operating stuff in Sydney. And so if you look at this, I think it's a BBC video, you can see how they actually operate one of their big mines, and a lot of stuff has become automated: explosions, huge big driverless costs. So it's not just a reduction in cost of operating costs, it's also a safety issue. I think lots of gold mining companies too have tried to automate more of their process in terms of safety. So again, this video sort of blew my mind when I saw it. It was quite interesting to see a massive mine run by a bunch of people sitting in Sydney with a bunch of joysticks, a little bit like a computer game, just moving trucks around and exploding things, and collecting copper. So Rio Tinto, another great example. Okay, so I've got a couple more examples to finish. Uh, and as I said, you could nearly every industry has been affected by these methods, by data science, by machine learning, by definitely by deep learning. And again, really, it's just the first innings. I think every company wants to have a data science team, and take the data they have and build interesting data sets. Well, some of these things are still in their infancy. So, for example, hiring an HR decision is a tough decision, and there's sort of two sides of the coin. On the one hand, you could argue that traditional hiring is biased, and you'd want to make it more transparent and more open. People have talked about that. There's a nice Harvard Business Review article. And so, as a simple question is, can AI eliminate unconscious human bias and, sort of accelerate the hiring process and get better matching between people and companies? So people have tried that. So Amazon tried that and it failed. So again, these systems are always getting improved. So something will come back and replace it. And I'm sure you yourselves have experienced more automation in the process of sending your CV and adapting yourself to these algorithms. And so it's a big topic, and also a topic where a lot of people have opinions because it's quite easy for companies and people to get things wrong. So it's an interesting article from 5 years ago where Amazon sort of got it wrong. Its AI algorithm was biased in favor of men over women, and I think when people went back to look at it, it was partly because the training sample was biased to begin with. So there's a big new area in academics of looking at fairness in AI. So there's a how does one assess the fairness of an algorithm? And there's lots of things that go into making an algorithm. The training data set, the model that's used itself. How do you look at fairness? And maybe there should be some form of test or sort of regulations where there should be some sort of universal test where each algorithm is given a whole bunch of test cases and seen how it performs on test cases to make sure that these biases are eliminated. So again, that's a big field that is certainly growing, the fairness of algorithms. It's also, I'm sure the lawyers are very interested in the ethics of AI. So I'm sure that will uh, keep keep people busy to discuss, what really is the ethics of deciding things with algorithms. And it's not just hiring; it's also firing people too. So there's been some horrible cases where people have been doing a great job, but the algorithm makes a mistake, and it must be psychologically quite disturbing to be fired purely by an algorithm. So there's an example on the more negative side. Another one that made the news that got people discussing it. So if you go to the Bloomberg article, one of the founding members of Apple, Steve Wozniak, came across this one too, and it was the issue of how you give credit to people when you were applying for Apple's new credit card or the Apple Goldman credit card. So that's an interesting story to go back and look at, and the responses of CEOs of Goldman and other such things is sort of something interesting to look at. And again, there's a lot in it. Remember that these algorithms are based on very large big data sets that can have quote unquote biases in to begin with, and sometimes it's actually when you've done these pattern matching things, it's no fault of the researcher, but sometimes it's hard to understand what the hidden features are that it's learned. A lot of these things are empirically learned, and you'd like to understand the decision process of the model itself. So again, there's a lot of work. I think once an algorithm has been developed, there's a lot of pre-testing, a lot of beta testing that needs to be done to make sure that it sort of does what it's designed to do. But of course, these algorithms make the process much more efficient, and I think it'd be wrong to say that there was no human bias in hiring decisions. So hopefully, it's a happy medium of combining humans and machines together that come up with better systems. Another area that's quite interesting for the people in finance is corporate reporting and AI. People have tried to study fraud on earnings reports. Uh, some of the famous examples of what words do CEOs use when fraud is found later. Also, I think Enron was one of the famous initial test cases. So people looking at using natural language processing algorithms to identify what are the type of things that people say in emails that again sort of lead to fraud, and then just plain reporting of financial information. So there's so much information out there, with so many possible documents to look at. Just mechanical downloads of 10Ks and 10Qs and machines reading them. Financial news, events when the government announces unemployment numbers and other such things. Now computer algorithms read these things very quickly, and people know how to reprice things quite quickly. So again, a huge area. And click on this article to get some sense of it. So still growing. And I think in the law business, again, because they dealt with so many documents or deal with so many documents, and I need to go, figure out what's happening. A lot of these things are becoming automated, and you can search and do lots of interesting things. Maybe you've all seen an Amazon Go store. I think I went into one of the first ones in Seattle and found it quite interesting, where you just walk in with your phone and you pick up whatever you want and you just walk out essentially. So it can figure out what you've bought. It can figure out how to charge you, and everything is just seamless. Their promotional video is actually very interesting. I enjoyed it very much. It gives a very good description of the deep learning piece. So if you think about it, if you're walking around a store, there's lots of things to think about, right? You have to have video footage of tracking people. You have to figure out what items have been taken off shelves, what items have been put back to shelves if people didn't want them. Prices. You have to give people feedback on the bill that they're actually getting charged. And so there's a whole bunch of sort of little algorithms. Remember that one of the nice things about AI, we've talked about it quite a bit, that you can piece together lots of different algorithms, and you can essentially model the whole experience of going through an Amazon Go store and make it as nice and as simple and as cost effective as possible. I think there's an Alibaba equivalent. I think Alibaba tried it in China, but they realized that it was so much more expensive to put in expensive cameras and software. It was much easier just to employ people at Chinese labor rates than to actually design these stores. So again, there's these fundamental laws of economics that even though the software is free, you still have to develop it. You still have to collect data. So that's sort of an interesting, maybe an interesting area for people to look at. But Amazon Go stores, and I'm sure you've all seen one. Okay, just to step back a little bit, there was an interesting New York Times article. Because AI is really coming to affect every area of our, hiring decisions, our healthcare decisions, tracking your healthcare with your Apple Watch, for example, or your transportation decisions, based on Google Maps, or going to pick up groceries in Amazon store. The FAANG companies, Facebook, Amazon, Netflix, Google, or Alphabet, basically have not a monopoly, or you could argue they have a very valuable data set, which of course they want to exploit for their shareholders and themselves. And so there's an issue of how open and free should all these data sets be, and how easy is it for people to look at. So as transparent as possible. And then there's an issue of how much the general public cares about such issues too. And I think different countries have different views on these things. I think the Europeans have different views than people in America. So again, another interesting area if people are interested in public policy. And I don't think these questions will go away for a long time. Just to give you some examples, another interesting New York Times article. It basically really just and I think just so you get a good sense of it, that AI has affected so many things. It goes from agriculture all the way to the end of the alphabet and all the way back again. So it goes from agriculture to art. Lots of very interesting problems. So let's just pick on agriculture for a moment. Over the last 100 years, there's been so many efficiency gains, but you can see that even more are coming. So a lot of satellites, imaging, a lot of looking back at the Earth, a lot of weather prediction models, a lot of trying to understand plant disease, how to optimally plant things, this type of stuff. And there's a lot of companies out there that provide very interesting agricultural feedback to people. In more developing countries, there's lots of small farmers that once they get linked up to the internet, they're much better coordinated. Uh, so, from the last 100 years of improvements in farming, maybe the next 100 years is improvements of just the data efficiency and tracking of things. So, again, another application of blockchain that you can see where your tomato was grown and delivered to you if you really want to. So, New York Times has a very good article on describing the just incredible wide range of applications of these things. You could argue there's an arms race. So I put one slide on these things. There's a foreign policy article that talks about it. I think elections is one that in the last 5 or 6 years people have spent a lot of time worrying about. Mark Zuckerberg at Facebook talks about it. What's the how exactly are these systems getting manipulated with AI behind the scenes? So there's one article for you. And again, it's quite easy to provide misinformation with these algorithms too, and it's quite easy to try and affect things. So I get another article for you, essentially how AI could be weaponized to spread disinformation. So it's very, very hard to monitor these things, and if you really are a bad actor, you sort of have a huge advantage to begin with because you can sort of see the system as it is, and you can design what you want to design based on that. Okay, some. Let me finish with a couple of more business examples. So Pinterest is a big company, and what's interesting to me there is that it was one of the first people that wanted to get into deep learning recommender systems. So one of the original applications of AI was just recommender systems. I think Amazon had their book matcher representative, recommendations. Given a history of books I bought, what book would I buy next, and then all the way down to YouTube. Given certain YouTube videos I've watched, what's the next ones I want to watch, and sometimes I joke with my friends that human beings could spend the rest of their lives. The recommendations of YouTube are so good that it'll just keep on serving you up, great information, and you can basically spend the rest of your life watching YouTube if you so desire, or watching Netflix. Well, Pinterest works on trying to recommend related pins to people, and again, they have a technology. Just like we talked about Word2Vec, they have a technology called Pin2Vec. And a lot of these things is, remember, this feature engineering piece of deep learning. What's the basic underlying idea? That I've got a huge big data set here of possible pins or images, and I want to do what's known as feature embedding, just like you solve natural language processing or image processing. And I embed this in a 128 dimensional space, and then from that, I fit deep learning to come up with what's the most likely pin that you would like to see. And as I said, sometimes these algorithms don't give you great recommendations. So I've seen some of the Pinterest ones, and they're not always great. But as time goes by and more users use these things, and data sets improve and algorithms improve, so do their algorithms. I guess the granddaddy of recommender systems is YouTube, and really sort of the granddaddy of, because it's processing videos. Remember, you need tensor processing chips, not just GPU chips, because it's such a huge big data set. And I'm not the expert. Clearly, I'm not the expert at creating views on YouTube. I'd be very happy if my Bayes AI course gets into the thousands or tens of thousands of views. Certain things get hundreds of millions of views. And Google is really there to try and help the people that put up content to try and make their stuff as addictive as possible, and to give them the biggest outreach as possible. And if you go to Google Analytics, or if you go to their research page, you'll see that they do lots of very interesting data sets where they take every single possible video on YouTube, slice it up into 6-second little pieces, and try and categorize what's in each piece. and to sort of help on search. For example, suppose you wanted to search for Lionel Messi scoring a goal. Well, that's not simple to go find those all those videos, but if you cut everything up into 6-second pieces and try to categorize computationally what's there, it's doing a better and better job. So they were one of the first algorithms to begin, and they're still going strong, and people still want to improve them. And really, recommender systems are really the underlying basis of what we consume in terms of information, social media in our lives today. So, and you have to remember that it's a bit of a game theory problem for the company that Google really is trying to maximize the amount of time spent you watching. So, I think you as a human have to realize that maybe there's maybe there's other things to do in life than just sitting in front of YouTube. And again, there's lots of interesting cognitive biases, and I'm sure that's the psychologists will spend a lot more time talking about biases or that are applied to these AI algorithms. So there's lots of well-known biases like confirmation bias that's been studied, and lots of other things of studying addiction versus shutting out other opinions and views and just forcing you down some rabbit hole of information. Uh, so again, I think I've already talked about YouTube, and as I said, there's uh, a lot of possible misuse of YouTube and Facebook as well. And I think you're beginning to see these companies tracking more carefully what gets put up and being more careful about what's there. So again, an interesting area. Don't forget music, Spotify. I don't know. I'm sure most of you have a Spotify account. How do you do AI for personalized music? What types of songs or harmonies and rhythms make you happy, make you sad, that type of stuff. So not just identifying songs, but identifying your emotional state as a function of songs. So people have tried to look at this problem. So there's an MIT Technology Review article about that too. Uh, at the end of the day, there's still humans involved in the process, and I thought this article would amuse you. That there was an example with Jane Fonda and the show Grace and Frankie, which I have not watched, but let me let me just read it. As the company plunges deeper into originals, its LA wing is doing the once unthinkable, overriding the metrics. So sometimes the machine algorithms get it wrong and offend people. And I think that the two people, if you read this one here, the two people that run Netflix have come up with this sort of 70-30 rule. So for them, it's 70% gut and 30% data. So if Netflix is not getting 100% taken over by AI, then there's still hope for the rest of us. I never like to end on too much of a sour note, but the healthcare analytics we already talked quite a bit about. Google Verily, still a very interesting area. So I've got a rather shocking title from an English magazine, New Scientist, where they took a big data set of basically 2 million electrocardiograms from 400,000 people, a whole bunch of time series data, and you could see that Apple could easily do this with their iWatch. It extracts features from the time series, and better features at identifying things than doctors can come up with. I mean, doctors can be very good, but with such a huge big data set and such good pattern matching skills that these AI algorithms can come up with good things. And the article found that AI predicted the risk of death more accurately than physicians. Although, as I said, there's always this duality that sometimes it's unclear what patterns that AI is picking up, and physicians are sometimes reluctant to use such algorithms. And again, another question is, do people really want feedback? would you really want to know that the AI algorithm thinks you're going to die in 7 years, 3 months, and 2 days? So would that change your life and make you any happier? So even simple things like genetic information on things like breast cancer and other such things, sometimes people are not sort of interested to know. Uh, what are the areas going forward? I think we talked about some today with policy and uh, hopefully interesting examples of where AI is growing and what it does well and what it does bad, and where humans have a lot of say. Again, another area, it's been started to be called explainable AI. So to try and get away from the black box approach, so looking at the features it finds, trying to understand how it's weighting features, trying to understand whether that's bad or not. Introducing costs of making mistakes. Lots of AI algorithms just pattern matching. They haven't put a utility. They haven't put an economic type cost on mistakes being good or bad. So another interesting area, explainable AI, and then for other people that think that AI will. So if you're in the Turing von Neumann Shannon camp of people that like to develop these algorithms, you think that these algorithms will themselves have general intelligence. So I think the problem there is called transfer learning. So uh, once I've developed algorithms to do certain tasks, if I'm given a new task I've never seen before, can I basically use a combination of old algorithms to solve a new task? Very similar to the AlphaGo Zero idea that there was no need for human input in the Alpha Zero idea. So that's called artificial general intelligence, and someone like Elon Musk would be worried that the AI is going to become smart enough to take over the world and decide that humans really aren't that useful. Okay, well that's the end of the class. So I hope you enjoyed the 9 weeks. I thought it'd be interesting just to end with one. There's a movie here if you click on it, but I thought this would sort of summarize the class nicely. That when I first started to do these things, uh, that the goal was to send a rocket to the moon, and so the Kalman filter and lots of machine learning and statistical techniques were developed to send somebody up to the moon. Where now in 2021 the technology's gone the other way around. Can we actually bring a rocket all the way back from space and actually land on a minuscule little thing sitting out in the ocean? So I thought SpaceX was a nice metaphor for the course, just to show that the incredible increase of what's happened with AI. Anyway, thank you very much for listening. I hope this has motivated you to take whatever you're interested in, take a look at AI, maybe have a read of the AIQ book, and get into some of these techniques, and to go and apply it, and to go and enjoy it. Thank you very much.